So this section of the book talks about acid rain, and I'm not going to test you on this, but I want to talk about it briefly because I think it helps make chemistry relevant to everyday life and shows that understanding chemistry is important, right? So humans use fossil fuels to generate energy. Some fossil fuels, especially coal, have trace amounts of sulfur in them. And so when you burn the coal, you're not only forming carbon dioxide and water, you're also forming sulfur dioxide. And that, of course, goes into the air. Any fossil fuel, regardless of whether it has sulfur in it or not, can react with nitrogen from the air and form NO2. Just because there's nitrogen present, and it can form NO2. So we've got these two gases being given off when we're burning fossil fuels. Well, SO2 can react with oxygen and water that are present in the atmosphere and make sulfuric acid. NO2 reacts with the oxygen and water that are present in the atmosphere and makes nitric acid. So now we have sulfuric acid and nitric acid in the sky, right? This is great. No, it isn't. So those acids combine with rain and they come down, and it's not good. The problem is actually biggest in the Northeast, not because they burn the most fossil fuels, but because of air currents that take the SO2 and NO2 produced by coal combustion in the Midwest, and they blow it over to the Northeast. And so we see most of the damage from acid rain happening in the Northeast. Rain is already somewhat acidic because the carbon dioxide, we just looked at how that is an acid, carbon dioxide reacts with water to form carbonic acid. But carbonic acid is a weak acid. So if we have rain that's saturated with CO2, it has a pH of about 5.6, which is acidic, but it's not really low. When you get nitric acid, sulfuric acid in the rain, then the pH can fall below 4.3. That's 20 times higher hydrogen ion concentration than the carbon dioxide. So this is a big, big difference in the acidity. And what does this do? Well, we know that acids dissolve metals and they react with carbonates. So this can affect anything made out of metal that's exposed to the atmosphere, bridges, railroads, the railroad ties, even automobiles. The acid in the rain can damage those. Anything containing carbonate compounds, marble, limestone, cement, the acid rain is gradually going to erode those substances. So we have images like this. This is a statue, and this one has been a little more protected from the rain, and so it's not as eroded as this one. But the one that we're seeing there is just like all deformed, right? It's like it was made out of candy, and you've been sucking on it for a long time. You're just dissolving the outside off, right? And that happens to buildings and sidewalks and all kinds of stuff. The rain falls in lakes and rivers, and that can affect the aquatic life. Interesting, I find this especially interesting because I come from the Midwest. So in the Midwest, there is a lot of limestone in the soil. Well, limestone is somewhat basic, and so you've got the acid rain falling into the lakes and the rivers, but you've got limestone from the soil, and so it neutralizes the acid, and so it's not really affecting the pH of lakes and rivers in places like Minnesota. But in the Northeast, they don't have very much limestone, and so then it does make the lakes more acidic. So you increase the acidity of the lakes and the rivers, and that affects the aquatic life. They can't live very well when the water is acidic. And then the trees, we see stuff like this. And this is not from the beetle that we have up here in the Sierra Nevadas. That's from acid rain. And it's not the acid like eating away the leaves, but the acid in the soil leaches away the nutrients, and so then the trees can't get the nutrients they need from the soil and they die. So back in 1990, which seems a very long time ago now, that's the year Dr. K and I got married, actually. There were amendments made to the Clean Air Act, and those amendments targeted acid rain by forcing utilities to lower their SO2 emissions. So, there's all kinds of penalties and stuff, and really motivating them to lower SO2 emissions. And so here's a graph showing concentration of SO2 in the air over time. So from 1990, it was up around 130-ish, and in 2013, last data, it's down more around 30. So the SO2 concentration in the air has gone down significantly in the United States as a result of the legislation. And what they observe in the Northeast, which has been especially hard hit by the acid rain, is that the lakes and the rivers and the soils are beginning to recover from that. So the government did something right. Any questions?